Hey guys, welcome back. So today we're going to be looking at perfect squares. Now what is a perfect square? Well, I've drawn a bracket here with the terms x and plus y inside of it, and then I have a squared on the top. We're going to call that a perfect square. A bracket with two terms inside with the bracket squared. So that's how you see a perfect square in its factorized form. You can see here that it's factorized because we have brackets. Now, if we expand these brackets, the easiest way to do that, logically, is to say, well, if we have a bracket squared, that is simply the bracket times itself, because anything squared is the same number times itself. So really, this is the same as x plus y times x plus y. Just like if you had x squared, that is the same as x times x. So we have this bracket squared, which is going to be the same as this bracket times this bracket. And we know that how to expand two brackets next to each other, we simply times each term in each bracket by each other. So we're going to do x times x times xy, which is x squared plus xy. Then we're going to do y times x, which can also be written as plus xy. We don't have to write it as yx. We'll write them in alphabetical order. And then we do plus y times plus y, which is plus y squared. So after expanding the brackets like that, remember this is the expanded form of this perfect square. We can see that we have plus xy and plus xy. And if we add those two like terms together, we're going to get x squared plus 2xy plus y squared. So this is the simplified, expanded form of this bracket, squared, which was a perfect square. That's what we're calling that. But that means that this is also a perfect square. This is just the expanded form, and this is the factorized form. So there's two ways of writing a perfect square. Okay, we can have the factorized form, which looks like this bracket squared, or we can have the expanded form, which again is where you have no brackets. You get rid of the brackets. What I want you to notice is that when we get a bracket squared, which we're calling a perfect square, really what's going to happen every time is because you're timesing that bracket by the same bracket, you're always going to end up with these two middle terms being exactly the same, because you would have times x by y and y by x. No matter what those two terms there were, you're going to have times them together twice. So you're always going to end up with double the product of these two terms. So what that really means is that if I get a bracket like this, let's call it a plus b squared. It's a perfect square now because it's a bracket squared. The shortcut would be just to say that it's going to be this first term squared. You can see here, x squared. So a squared plus, and again, this sign depends on the sign there. What is the product of these two terms? Well, what's x times plus y? X times plus y was xy. And then you double it. As you saw, you're always going to end up doing two times that product. So x times y gives you xy, and then times 2 is 2xy. You can see that that will always be the middle term. So we're going to go over here, we're going to get a times plus b, which is ab, times 2. So 2ab. And then the last term is always going to be this last term squared, which is b squared. And it's always going to be plus, because even if that was a minus, even if it was a minus b squared, minus b times minus b squared is plus b squared. And by the way, when you do this bracket, the only difference is you're still going to get the first term squared, but then you're going to notice that the middle term, because it is, to find out the middle term, remember there's three terms. The first one's going to be the first term squared, the last one's going to be the last term squared, and the second one is going to be a, I'll write it here, a times minus b, we're just timesing the two together in the bracket, which is going to equal minus ab times 2. times 2, which equals minus 2ab. So don't forget that the negative is important in that it's going to become minus 2ab. And then again, minus b times minus b is plus b squared. And if you want to check any of this, or when you do a question, you're not sure of this shortcut, you can always go back to the long way where you just write the bracket times the bracket and do the long expansion, and then you can add them together. But this is a shortcut. These are shortcut rules. So here are your rules. Okay, so let's have a look at a couple of examples of these. Just get rid of these. And hopefully this makes it clear. The first one, we'll say y minus 2 squared. Well, it's going to equal, according to this formula, the first term squared, y squared. Then it's going to be these two terms times each other, times 2. So y times minus 2 is minus 2y, times 2 is minus 4y. And then it's going to be this last term squared. What's minus 2 squared? Plus 4. So that is the expanded form of this perfect square. Here is a perfect square, and here is a perfect square. They're just two ways of writing the same thing. Okay, number 2 is going to be, let's make something a bit different, 2x plus 3y squared. Again, it's a perfect square because we have the bracket with two terms inside squared. And we're going to say, well, the rule is that it's going to be this first term squared, which is 4x squared. Don't forget to square the 2 as well. You have to square everything in the term. So it is 4x squared, because 2x squared equals 4x squared. And then we say the middle term, the next term, is going to be 2x times plus 3y, which is 2x times 3y is 6xy. And then we're going to double it. Remember, we would have done that twice if we did it the long way. So we say it's plus 12xy. And then the last term is going to be this last term squared. Over here, it's 3y squared, which is going to equal 9y squared. Don't forget to square everything in the term. So you get plus 9y squared. So that is the expanded form of that perfect square. Okay, the last thing you need to know is how to identify the perfect square if it is not in the factorized form. So you just see it this way to start off with. Well, let's have a look at that situation. Okay, now you get something that looks like this. X squared minus 6x plus 9. Now, how do you know that that is a perfect square? And this is how you tell. And you can only really do this off the top of your head if this first term on the x squared, or whatever pronumeral it is, whatever letter is there, has a 1 before it, okay? So if you get x squared, and then you get two other terms, remember there has to be 3 terms in a perfect square, then there's a way of identifying whether it is a perfect square, okay? So if I have x squared minus 6x plus 9, the way you tell is that half of this minus 6 term, so minus 6 halved equals minus 3, okay? That means that minus 3, because remember that this middle term was double the two terms that were in the bracket in this. We're obviously trying to find the two terms that were in this bracket. I need to find what goes there and what goes there. And I know that if I times those two terms together and doubled them, I got this term, minus 6x. So therefore, half of minus 6, forget about the x because the x would have just been there, half of minus 6 equals minus 3. That would be the number that goes here. Okay, so half of minus 6 is minus 3, and minus 3 squared, I'm going to bracket the minus 3, equals 9. And that's that one. Because in the bracket, if I had x minus 3, so remember whatever half of this middle term is, this is only when you have the 1x squared situation, 3 is going to be the number that goes in there. And we know that the last term of a perfect square is always this term, which is half, squared, right? Because you go x squared minus 3 times x times 2 minus 6x plus 9 because it's minus 3 squared. So because minus 3 squared is 9 and we have 9 there, we do have a perfect square. So that is how you check. If there was any other number besides 9 there, then it would not be a perfect square. All right, thanks guys.